Welcome to the DIY Honda Garage channel. The DTC P0010 indicates a malfunction within the variable timing control VTC oil control solenoid valve in the Honda CRV models from 2011 to 2016. This issue typically arises when the solenoid valve fails to regulate oil flow properly, affecting the timing of the engine's valve system. The solenoid is responsible for adjusting the camshaft timing to optimize engine performance and efficiency, which directly impacts fuel economy and emissions. The location of the VTC solenoid is usually near the engine cylinder head, integrated into the timing mechanism. Understanding this DTC is crucial for efficiently diagnosing engine performance issues. In this troubleshooting guide, we will work through a series of steps to identify and rectify the underlying problem, ensuring that the engine runs smoothly and adheres to emission standards. DTC P0010 represents a malfunction concerning the VTC oil control solenoid valve, which plays an integral role in managing the engine's variable valve timing. The solenoid valve directs oil flow to modify the camshaft's position, allowing for optimal performance and efficiency under various driving conditions. Such adjustments help maximize fuel efficiency and minimize emissions, making it crucial for the engine's overall health. Typically, the VTC oil control solenoid valve's location is situated at the top of the engine, near the cylinder head, where it can directly affect valve timing. When the engine control module, ECM, detects an issue with this valve, it generates the DTC P0010, indicating a need for immediate inspection and correction. Hence why this guide is essential for effective diagnostic and repair processes. Several factors could lead to the DTC P0010 in your Honda CRV. Firstly, a faulty VTC oil control solenoid itself may hinder its ability to regulate oil flow properly, resulting in malfunction. Additionally, an open circuit in the PG1 wire, which connects the solenoid valve to the engine control module, may disrupt the signal pathways necessary for correct operation. Another potential issue could be a shorted VTC P wire, which may also lead to signal failures and erroneous readings. Lastly, poor connections or loose terminals at the VTC oil control solenoid valve and the powertrain control module, PCM, can result in intermittent DTC recordings, leading to compromised functionality. Understanding these potential causes is the first step towards effectively diagnosing and resolving the issue. Identifying the symptoms associated with DTC P0010 is essential for diagnosis. The most immediate indicator is the illumination of the check engine light on the dashboard, signaling a malfunction within the engine management system. Drivers might also experience noticeable performance issues, such as poor acceleration or rough idling, as the malfunctioning solenoid impairs proper valve timing. Additionally, reduced fuel efficiency may become apparent due to the engine not operating within its optimal parameters, leading to higher fuel consumption. Increased emissions can also be a direct consequence due to improper air-fuel mixture as a result of suboptimal engine timing, contributing to potential failure during emissions testing. By recognizing these symptoms, technicians can pinpoint issues more accurately, guiding them in the troubleshooting process. The first troubleshooting step involves confirming the presence of DTC P0010 through direct interaction with the car's diagnostic system. Begin by turning the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. Next, connect the HDS Honda Diagnostic System and clear the DTC. This step is necessary to reset the fault memory, allowing for fresh diagnostic readings. Once the DTC is cleared, start the engine and maintain a steady speed of 3,000 RPM without any load for a few minutes, until the radiator fan activates. After this, perform the VTC test in the HDS's inspection menu. This test will assess the functionality of the VTC system and potentially confirm whether the DTC P0010 is indicated again. If it is, the failure persists, indicating that the subsequent steps should be taken for further investigation. In this second step, the focus shifts to examining the internal resistance of the VTC oil control solenoid valve to ensure it operates within the specified parameters. Start by turning the ignition switch to the lock 0 position, ensuring that all electrical systems are off for safety. Next, locate and disconnect the VTC oil control solenoid valve's 2P connector. This connector typically houses two wires that facilitate communication between the solenoid and the PCM. Once disconnected, use a multimeter to measure the resistance between the two test points on the solenoid's connector, specifically test points 1 and 2. The expected resistance value is between 6.75 to 8.25 ohms at room temperature. If the reading falls outside this range, indicating a short or open circuit, this confirms the solenoid valve is faulty and requires replacement. If the resistance is within the limits, proceed to the next troubleshooting step. The third step in troubleshooting DTC P0010 involves checking the continuity of the PG1 wire that connects the VTC oil control solenoid valve to the PCM. Begin by keeping the ignition switch turned to lock 0 and ensure the VTC oil control solenoid valve's 2P connector is still disconnected for safety. Utilize a multimeter to check for continuity between test points 1 and 2. The first test point corresponds to the second terminal of the VTC oil control solenoid valve connector, while the second test point should be the vehicle's body ground. Achieving continuity confirms that the PG1 wire is functioning correctly. If no continuity is detected, it indicates an open circuit in the PG1 wire, necessitating repairs along the wire's path towards the body ground G101. This step is crucial for ensuring proper communication between the solenoid valve and the PCM, as any break can result in malfunctioning diagnostics. In this penultimate troubleshooting step, the aim is to identify any potential short circuits in the VTC-P wire. Start by utilizing the HDS to jump the SCS, service check signal line, enabling specific diagnostic functions. Following this, disconnect the PCM connector C, which houses several crucial connections for the vehicle's operation. You will now check for continuity between two test points. The first at the PCM connector C's number 33 pin, identified by its blue wire, and the second at the body ground, ensuring that the path is intact. A successful continuity test signifies that the VTC-P wire is not shorted between the oil control solenoid valve and the PCM. If continuity fails, immediate repairs in the wiring must be undertaken to rectify the short circuit issue, ensuring proper functionality of the VTC system. The final troubleshooting step centers on confirming the continuity of the VTC-P wire to the PCM to ensure no open circuits exist. Again, with the ignition switch in the lock 0 position and the VTC oil control solenoid valve's 2P connector disconnected, utilize a multimeter to assess continuity between the first test point on the solenoid valve connector and pin number 33 of the PCM connector C. If continuity confirms a successful connection, the VTC-P wire is intact. However, if no continuity is found, it's indicative of an open circuit along the wire heading toward the PCM. In this case, repairing the open circuit is critical to restoring proper communication between the solenoid valve and the PCM. If the circuit is confirmed to be functional, ensure the PCM has the latest software version, and if not, perform an update or install a known good PCM, setting the stage for successful operational testing. After completing the troubleshooting and any required repairs for DTC P0010, it's essential to perform a comprehensive repair verification to ensure the issue is fully resolved. First, reconnect all electrical connectors previously disconnected during the diagnostic process, ensuring secure and proper connections to avoid further issues. Turn the ignition switch to the on. Turn the ignition switch to the on position to power the vehicle systems. Utilize the HDS to reset the PCM, effectively clearing any stored diagnostic trouble codes and preparing the vehicle for a fresh test cycle. After resetting, the system needs to undergo the PCM idle learn procedure, allowing the PCM to recalibrate its learning parameters for optimum performance. Then, conduct the VTC test from the HDS's inspection menu to verify that the VTC oil control solenoid valve is functioning properly and that no faults are present. This step ensures the engine is operating within specification, finalizing the troubleshooting process. Preventive maintenance is critical in avoiding future issues indicated by DTC P0010 related to the VTC oil control solenoid valve. Regularly inspecting the wiring associated with the VTC system can identify any signs of wear or damage that may lead to failures. Likewise, keeping the PCM software updated ensures that the engine management system operates with the latest parameters and corrections. This minimizes the risk of faults developing due to outdated programming. Additionally, monitoring engine performance periodically can detect any inconsistencies early on, allowing for timely repairs before issues escalate into serious malfunctions. These proactive measures can not only enhance the longevity of the service components, but also ensure peak engine performance and compliance with emission standards. In conclusion, DTC P0010 signifies a malfunction within the VTC oil control solenoid valve, critical for optimal engine performance in the Honda CRV models from 2011 to 2016. Effective troubleshooting is essential to identify the root cause, whether it be the solenoid valve itself or related wiring issues. By following a structured diagnostic procedure, technicians can ensure accurate repairs are made, minimizing downtime and restoring vehicle efficiency. Additionally, engaging in regular maintenance practices is vital in preventing future issues and ensuring the longevity of engine components. Understanding the underlying mechanics of the VTC system equips vehicle owners and technicians alike with the knowledge necessary to address and repair these common automotive challenges efficiently. Please like and subscribe to the channel. See you next time.